Hello everybody, this is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. This presentation I want to explain Introduction to Dielectrics. We know according to the conductivity, the materials or substances can be classified into three types. The one is conductors, second one is semiconductors, and third one is dielectrics. So, depending on the free electrons in a conductor or in a material, the substances can be classified as follows. The first one is conductors. Any material or any substance which allow electricity to flow through them are called conductors. In case of metals, all metals, there is free electrons. It means it does not contact with the nucleus. Such electrons can freely move from one place to another place through the material. Such materials act as a good conductor. So, materials are substances which allow electricity to flow through them are called conductors. So, examples of copper, gold, silver, etc. All metals are good conductors. Of course, even human body also a good conductor. So that are the examples. So these are copper and gold and silver, etc. are the some of the examples of the conductors. In this, the discussion or study about the conductors may discuss in current electricity chapter. Ohm's law, Kirchhoff laws, all these are can be applicable to the conductors only. And second one is semiconductors. Materials or substances which allow electricity partially through them are called semiconductors. And the examples are main examples are silicon and germanium. Not only them, most of the metal oxides are good semiconductors. Nowadays, the total electronics technology is depending on the semiconductors. So you see here, all these electronic chips are prepared with the semiconductors. This electronics, in the electronics chapter, we will discuss about most of the semiconductors, junction diode, Zener diode, transistors, all are prepared with the semiconductors. Dielectrics, materials or substances which does not allow electricity through them are called dielectrics and also called insulators. We know examples are wood, paper, plastic, ping on, etc. We know in our house domestic purpose also all the switches are made with the plastic. It is a good insulator or a good dielectric material. Not only that, the fuse boxes in fuses are prepared with the pingani. That is a good conductor, good insulator, the good dielectrics. So these are the some of the examples of the good dielectrics. So how many types of dielectrics we have? There are two types of dielectrics. One is non-polar dielectrics and second one is polar dielectrics. And also called non-polar molecule and also called polar molecule. So before discussing about these types of dielectrics, we want to see into the depth of the atom. We know any atom constituting a nucleus having positive charge and electrons revolve around the nucleus having a negative charge. Of course, molecules maybe have maybe one more atom or two atom or maybe multiple atoms. In any molecule, there is a number of nucleus. Then the center of gravity of the positive charges can be concentrated at one point, and the center of gravity of the negative charges, that is electrons, can be concentrated at one point. If these 2 points concentrated at a single point, then this is called nonpolar molecule. So in which this positive charge and a negative charge coincide each other. So when the negative charges of center of gravity and the positive charges of center of gravity coincides, such molecule is known as nonpolar molecule. Some of the examples of nonpolar molecules are hydrogen, nitrogen, oxygen, carbon dioxide, benzene, etc. And what about polar molecules, in which the negative charges of center of gravity and positive charges of center of gravity does not coincide? It is nothing but positive charge and negative charge kept at some distance. These molecules are called polar molecules. When the negative charges of center of gravity and the positive charges of center of gravity does not coincide, such molecule is known as polar molecule. So you see here there is one positive charge and a negative charge kept at some distance. So these are the example of the polar molecules. Examples of hydrogen, hydrogen chloride, carbon monoxide, nitrous oxide, ammonia are some of the examples of polar dielectric molecule. So there is some distance between two positive charges, that is positive charge and negative charge. So this is just like act as a dipole, so it has a dipole moment. So any polar dielectric molecule having permanent dipole moment is represented by small p. So what is dipole moment? So before discussing about the dipole moment, what is dipole? Dipole is nothing but there is a two equal and opposite charges, small in magnitude and separated by a small distance, constitute an electric dipole. So electric dipole containing two equal and opposite charges kept at some distance is called electric dipole. So any dipole having the electric dipole moment. So dipole moment is equal to the product of the magnitude, that is q, and the separation or the distance between them is called dipole moment. So the dipole moment small p is equal to charge into distance, that is q into 2a, that is 2aq is the dipole moment. So what are the units of dipole moment? Dipole moment, there is a charge into distance, so that coulomb into meter is the units of dipole moment. So when this nonpolar dielectric is kept in electric field, then what happens? When non-polar dielectric material, when kept in electric field, how changes occurs inside of the dielectric, now we will discuss. So this is the non-polar dielectric. It is nothing but there is positive charges and negative charges are there. The center of gravity of the positive charges and the center of gravity of the negative charges are coincide at one place. So here's a dipole moment p is equal to 0. When this dielectric material, that is non-polar dielectric material, is kept in electric field, that is in between capacitor plates, where A and B are two capacitor plates, there is some potential between A and B, or intensity of electric field between A and B. This is E naught is the intensity of electric field in between two capacitor pairs. When this dielectric material kept in electric field, positive charges are moved towards the negative plate, negative charges are moved towards the positive plate. This phenomena is called dielectric polarization. So in the third diagram 3, there is positive charges and negative charges are distributed at both sides. So some intensity of electric field is induced, which is opposite to the original electric field. So original electric field E naught and induced electric field E dash are opposite to each other, so that the resultant intensity of electric field E is equal to E naught minus E dash. So that the resultant electric field E reduces when this polar non-polar dielectric kept in an electric field. So in detail we will discuss now. So as shown in this figure, first figure 1, positive charges and negative charges are randomly distributed as shown in this figure, so that the resultant dipole moment is 0. And when the dielectric is placed in between capacitor plates, as shown in figure 2, that is in between capacitor plates A, B, having intensity of electric field E along this direction, there is negative charges moves towards the positive plate and the positive charges moves towards the negative plate. This phenomena is called polarization of dielectric. So polarization is says that what is polarization? Polarization is that the positive charges in the dielectric will move towards the negative plate and any two charges are moves towards the positive plate is called dielectric polarization. So, as shown in figure 3, induced charges, that is, these are the induced charges, minus and plus. That is, maybe it is taken as minus q dash, and this is plus q dash are induced charges in a dielectric. So that there is induced electric field is exist opposite to the E naught, that is E dash. So E dash is the induced electric field. So that is opposite to the E naught. So that the resultant field E in the dielectric is vector sum of E naught minus E dash. This is E is equal to E naught minus E dash. That gives the resultant intensity of electric field in a dielectric when kept in intensity of electric field. Thus, if the dielectric is placed in an electric field, induced surface charges appear, which tend to weaken the original field within the dielectric. Now we will discuss about what is polarization once again. So in the previous concept we discussed about definition. Now mathematically how can we write polarization? So before discussing that, once again we will remember what is dielectric polarization. So in dielectric polarization, when the dielectric is placed in between capacitor plates A, B, negative charges moves towards the positive plate, positive charges moves towards the negative plate. This phenomena is called dielectric polarization. So when these distorted atom is called as act as electric dipole, because we know electric dipole having positive charge and a negative charge kept at some distance. So in this also there is negative charge, that is minus q dash, and there is plus q dash. This side, this plus q dash are kept at some distance, kept at some distance. So this act as a dipole, so it has some dipole moment. It has some dipole moments. So the dipole moment per unit volume is called dielectric polarization. So the dipole moment per unit volume is called dielectric polarization. So how can we this calculate this dielectric polarization? So let us suppose a rectangular block having area of cross section A. At this A is area of cross section A, and its length is taken as L. When this block is kept in an electric field, there is negative charge is induced at the ABCD plane and a positive charge is induced at the PQRS plane. Here there is positive charge is induced. So it acts as a dipole. So there is some back in a dipole moment. So according to this, the dipole moment can be written as q dash into L, because L is the distance between two surfaces and q dash is the induced charge. Hence the dipole moment per unit volume is equal to dipole moment by volume per unit volume, because so we know dipole moment is q dash L, and we know volume of the this block, that is rectangular block, is equal to A into L, because A is the area of cross section. So in this L and L is cancel each other, so the dipole moment are per unit volume, that is also called polarization, P is equal to Q dash by A. So according to the definition, we know dielectric dipole polarization is equal to or numerically equal to dipole moment per unit volume. So that this dipole moment per unit volume, that is equal to dielectric polarization, is equal to Q dash by A. So Q dash by A is also called surface charge density, induced surface charge density. So the induced surface charge density or induced charge per unit area is called dielectric polarization. Thank you.